Hi, this video is for my A-level electronics students who are about to start building their microcontroller based circuits on breadboard. Now this is not a finished or in any way a final circuit. This is a prototype, and this is the sort of thing that I would expect you as A-level students to be able to build. Reasonably neat. It won't be what you will submit, because when you submit you're going to have to strip out all of these jumper wires and strip your own wires using just short wires arranged horizontally and vertically. It's going to look even neater than this, but for prototyping purposes, just to check that your ideas work, I'm quite happy for you to use these jumper wires. Note that I've clipped them together to actually make it a little bit firmer and reduce the chance of them coming out. So I'm going to give you a little bit of advice. First of all, when you build your prototype circuit, do mount this breadboard on a backing board like this. Okay, now in the classroom we've got some pegboard, the stuff which has got lots and lots of holes, or we could laser cut some more of these, but these make it a lot more sturdy, and then you don't have your problem with, say, your battery pack falling away from the breadboard or whatever. On the subject of the battery pack, do cable tie your battery pack down into position. I find that that solves a lot of problems. It means that you don't have strain on any of the wires, and also it means that someone doesn't borrow your batteries, if you know what I mean. So having got the battery pack and the breadboard down, I then recommend setting up the power rails. Now, by convention, I strongly recommend you have 0 volts down the bottom, and then you have your positive supply along the top. Now I've got a 6-volt battery pack, and that's more than is suitable for the PICkit microcontroller, which is just hiding under there, but that's no problem because I've got a reverse polarity protection diode which is going to drop me 0.7 volts or thereabouts anyway. So at the most the rail voltage is going to be about 5.3 volts, so that's okay. But if you use a 6-volt pack, do make sure that you include that diode, and if you want to go 4.5 volts, say, then you don't have to have that diode there. But having a diode is a good idea just in case you touch the connector on the battery pack the wrong way around, or you put your supply in the wrong way around. Okay, so having set up the power rails, or the supply to the power rails, I would also recommend, before you forget to do so, to add some little mini jumpers, for want of a better word, going from one row to the next row, because remember, just like these colours signify that that's not continuous, there's a break there, okay, both at the bottom and at the top of the breadboard. I also recommend having some extension wires going from the positive supply on the breadboard, taking it down to, so we've also got a positive supply down here, and also the same with the 0 volts as well. It's really convenient being able to tap into the supply both at the top of the board, or towards the top of the board and towards the bottom of the board. Really do recommend that. It can make things a lot easier later. What else then? Next I would include a power on indicator. It's got nothing to do with the PICkit, and all it's going to do is when you turn your power on, and hopefully you're going to include a switch, it's just going to show you that the power is applied to the rails. That's really useful because later on perhaps you forget that you've turned the power on, or you forget you haven't turned it on. So having that indicator is good because maybe you won't have any outputs on. And also another advantage on having a power on indicator like that is if you accidentally short out the board, say you connect the power supply straight, or have a straight short between the positive supply and ground, then that LED is going to go out, so that should warn you that something bad has happened. On the subject of the LED, do trim the legs of the LED down, okay? Keep them to a sensible length. The next thing that I would do, or the next thing that I did in setting up this board, I placed the ICSP header that we made some of these up in class. They're quite easy to make if you remember, and I placed it towards the left of the board, and I made sure that the PICkit wasn't going to hit anything. You can see I've got quite a close margin there, but I haven't quite hit that resistor, and I'm not hitting any other things, so that seems to be a sensible location. If you forget to check whether it's hitting stuff and then you add a load of wires and then you realise that you've got to shift everything around, it's a pain. So place that header connector in there as one of the early things. The next thing that I would do then is to place the PIC. Okay, so I've gone just slightly left of centre because I know in my particular application that I want to have a load of outputs and I'll probably have a few inputs. It's always a good idea as you build up your boards to keep the inputs on the left, so you've got like input, process and output. It just makes things easier for you. You don't have to do it like that, but I do recommend doing that. Now when you place, and it's difficult for you to see, most likely difficult for you to see, but take my word for it, pin 1 is bottom left, and it's really convenient in the class. It's going to be convenient to you if everyone puts their chip in the same way round. So if you then want to talk about stuff, show your project to other people, share ideas, whatever you're doing, it's useful if everyone's got their chip oriented the same way round. It actually happens to be convenient on this chip as well, that the ground pin is then going to be on the lower side and the positive supply VDD is going to be on the upper side of that chip, one of those, or it's the middle of the top pins along there. It's not always like that with chips, but you know, on this one, the PIC16F88, it is that way round. Now, then I would then connect up the power to the PIC. I would also connect up all the wires that you need from the header to the PIC, and don't forget you're going to need to add a resistor in somewhere as well. You should know about that. I don't need to tell you everything in this video. And without connecting any switches, without connecting any LEDs, just check that you can program that PIC, because if you can't, there's absolutely no reason to add a load more wires and just cause more confusion to yourself. So assuming that you could program that chip, I would then start adding some components. And personally, what I do, I like to add the outputs first. So in this particular instance, I've added 2 banks of LEDs. They're just LED arrays. Now you could use discrete LEDs like this. There's nothing wrong with that. But because I know that I'm going to have a whole bunch of outputs, I think that's more compact. So if you're going to have a lot of outputs, just ask me for one of these and I can give you one of these LED arrays. The same goes for resistors as well. So I've got, because I'm using so many of these outputs, I would need a current limiting resistor for each one of those LEDs, and rather than having resistors like that, I've just gone for a single inline resistor. Let me just pull that one out. So it looks like this, and they've got a common connection, so each one of these is going to have the same value between that pin and the common, and that pin and the common, and that pin and the common, and it makes it really easy for you to make a neat breadboard because you haven't got a load of resistors or separate resistors in there. Okay. I'm not using quite all of the segments in the LED array, so I don't need to extend right the way across. You can see that I'm only using, so a certain number of them. What I would then do, having connected up your outputs, you've got to write a test program to check those outputs work. Don't go any further. Don't write your final program or what you think is going to be your final program and then get really stuck and then don't know what's going on, and perhaps you just didn't set your outputs up correctly. Maybe you've connected the wires up incorrectly or something else. Okay, so make yourself a very, very simple program, a test program, to check that your outputs work. I'd then also connect up my inputs, and this input, I've only got one input at the moment. This is just power on, power off. But I would recommend then writing another simple program just to check that the input's working. This one I'm actually going to be using as an interrupt, but you could just check it by polling RB0 as well. So make yourself a simple test program, just check that your input's working. If by that stage you haven't tidied everything up, I recommend using some cable ties. You don't have to go completely OTT with loads and loads of cable ties, just a modest number. but I like to cable tie them up. It does make it a little bit more difficult to trace one wire to another, but bearing in mind I've already checked that it's working, so it should be alright. And I like to cable tie them because it really adds a lot of stiffness, and it means that one of these individual pins is much less likely to come out the board. It's no exaggeration to say that a lot of problems are encountered on breadboards because pins are not pushed in securely or they've come out. But to be honest, I think most student problems are just you've wired it up incorrectly. But beyond that, I think there's a lot of problems that are just due to the nature of breadboards and wires coming loose. So if you can make it a little bit more robust by adding a few cable ties, I think that's a really good idea. Also, I think, because once you've connected everything up, it might be fresh in your mind at that point, but it would be worthwhile adding yourself a few notes. Just get a little bit of masking tape, don't need any proper labels or anything, masking tape, and just write down some stuff. So I've got my left LED array, this one, and I've got my right LED array, and then so I've just made a quick note to show me that these right hand most 4 LEDs, that's RB2, RB3, RB4 and RB5, like that, so I won't forget. These ones, RA0, RA1, RA2, RA3, RA4. Notice that RA5 is not connected because RA5 is multiplex with MCLR and I don't want to use that. And then RA7. On the note of some of the pins are multiplex, so for example PTC and PGD are also multiplexed. I would recommend not using the pins that are multiplexed with things like MCLR and PGD and PGC. Leave them as they are, don't connect to anything else because there can be a problem. You could be, if you're say also having an output on the PGD or PGC, you might have a problem due to capacitance that you're adding in, and there's a whole load of other issues, so just don't do it would be my advice. Now finally, A-level students have got to understand that if you submit a project like this, which is it's quite neat, it won't get you the full marks. The mark scheme requires you to use short wires that are down to the breadboard level, not like this, not sticking out. And so the only way you can do that is you're going to have to get some solid core wire, strip off, and then make it the exact right length and flat down to the board. All those wires must be arranged horizontally, across, and vertically, up and down. And no wires should cross any other components like, say, the PIC chip. So, like I said, I mean, this is absolutely fine for prototyping your breadboard idea, but when you submit your coursework, don't submit it like this, please. I'll probably just give it back to you, because although this may work, it may function exactly what you want to do, you want to get the best mark, I'm sure. So make sure that everything is short, neat, horizontal, vertical, and right down to the board. Okay, I hope that's useful.